Next, I want to look at patterns. So I think it's a bit unfortunate that if you have multiple variables in scope, you can kind of bundle them all up in one single line, in one single expression, but you cannot do the opposite. You cannot kind of extract multiple of these bundled up values into individual variables in a similarly concise manner. So for example, if we have some do something function that accepts a position with x, y, and z, we can't do something like this. And I think that should be possible. Like, I think that would make a lot of the code more readable. Yeah. I'm not sure about just starting with that directly. I may require like parentheses around that to like, you know, kind of signify that this really is like a singular pattern thing. But yeah, still. Because I don't even know how multi-line patterns would even look like. You know, if you could have multi-line patterns like, what, something like this. That is, you know, this quickly gets ugly. So I think I only want single line patterns, and I'm fine with these being in parentheses. I think that makes things a little bit easier. To be clear, I don't want any sort of pattern matching. You know, I'm totally okay with just having a switch, like in here. You're switching on an enum, and then you have the individual branches there. I don't think for Plum that pattern matching is really a good fit, because pattern matching requires equality checking. And, you know, like, I don't know, you have some value, and then let's assume we have something more general than a switch. Something where you can say, well, if this is 1, I actually want to do that. If this is 2, I actually want to do that. If this is a string, I actually want to do that. If this is, I don't know, the enum variant true, I actually want to do that. Well, you know, this probably doesn't make any sense, because these should have static types. But even like among numbers, this might seem reasonable, but there is some sort of limitation. Like, this only works for the primitive types, I guess, like numbers. As soon as you have something like lists in the standard library, for example, lists, actually array lists, and they contain an array. And how are we supposed to compare two lists? They may have different arrays internally. They may, you know, even though they represent the same array with, you know, like length 2, but then there's an array with 8 items inside, with space for 8 items, and like, we don't want to compare the rest of these items. We only want to compare the first 2. And yeah, that means that comparing lists is kind of very type specific. It depends on the list. The same goes for comparing hash maps, for example, because the order of insertions may change how a hash map internally represents the same semantic data. All of that is a convoluted way to say that equality checking is not as easy. I could maybe define, you know, like matching on numbers, but as soon as I get into, but that's like a special casing for ints. As soon as I get into more complicated data structures, this doesn't work anymore. So yeah, I think pattern matching is not a good fit for Plum, because in Plum, values have no associated functionality, such as equality checking. Instead, I think all operations on values that actually, you know, change control flow and so on, they should be invoked specifically. like you don't want to be able to there is no way to override equals and then have custom like match ways of matching these numbers. Yeah, so I only want patterns in positions where in places where you already know the shape of the data. That's basically what I'm trying to say. So that you can then do something like x plus y plus z. Okay. And here you can do something with that struct, maybe. All right, let's just try to compile that, see where that fails, and we'll go from there. Yeah, and here we do need an equal sign to denote the body. This returns something different than it claims it returns. That is indeed true. Yeah, it does not return a string. All right, that is certainly an error. Variables have to be lowercase. Yeah, okay. So when compiling a function, we actually look on the left of the equal sign. And we check that that is like a lowercase name. Yeah, rather than doing that, I think I want to try to convert that into a pattern. What kind of patterns are there? I think you shouldn't, like not everything can be converted into a pattern, you know. I can't do something like 5 equals x, because 5 is not a pattern, because not every int can be converted into, like you have no compile time information about the int. This is not something that describes or that unwraps the shape of that x. Yeah. All right. So ints, they are not patterns. Names certainly are patterns. You know, you should be able to do this. This really is just a pattern with a name on the left. You can have structs, and again, I want to support this shorthand syntax, and I want to support giving like explicit names to these fields. So now we'll have A, Y, and Z in scope. Yeah, enums, I'm not sure about those. I guess if we have an enum with only a single variant, you know, something like foo is an enum that is always foo, and it contains, I don't know, an int. Then if you have some sort of foo, maybe you should be able to do this. Because you know that this is an enum with only a single variant. Yeah, put that in parentheses. Because you know that, you can kind of unwrap the payload of that variant. I'm not entirely sure about that, but yeah, maybe that is something worth looking into. Okay, so I think what I want for this thing on the left is compile that into a pattern, basically. And I think I'll just have a different function for that. Something like compile pattern. That is given the body, the module, the visible stuff, and the context, whatever that is. I'm not entirely sure. Yeah, like that. And then compile pattern introduces visible variables, and it kind of emits multiple, it may emit multiple operations on the body. Hang on. I think actually this should be the other way around. We first want to compile the value on the right, because that gives us an ID, and compile pattern should also take the ID of whatever expression is matched to that pattern. And then this compile pattern function, it can actually type check stuff. It can check that this right ID thing, that if we have a struct in here, a struct with x and y and z, it can check that this expression that it's given, that actually is a struct containing those fields. Yeah. So pattern, and then we don't need to define something visible, because the pattern already does that for us. That is pretty cool. That is honestly very nice. Yeah, so let's add a new function, I guess. I'm not sure where. Let's maybe compile this signature and then just put the function down below here. Push cast. Well, I may want to refactor how I'm building the yogurt, I think, later. So this is kind of the matched expression. Well, not matched, it's kind of the, yeah, I guess, to match patterns against something. It is guaranteed to always match, but a value, something like that. Oh, and maybe put that after the toast. Yeah. Okay, and this will have a similar structure to this one. So let's take that, let's copy that down here, and then trim that down radically, because it only supports a very limited subset of expressions in patterns. For example, ints are not valid patterns. For ints, we just, I think let's actually pull that OK, that result construction into these switch cases. Because for a lot of switch cases, patterns are just not valid. So having that be the default is kind of not what we want here. Dang, that's long. I mean, yeah, it's basically the entire semantic compilation and analysis. So here we are just emitting an error. I'm wondering, do we need this? I don't think so. Like a pattern, the cool thing about a pattern is it produces visible variables. It doesn't, it's not like some expression that you can use in some useful way. So let's actually look at the variable. Yeah, here again we don't use the pattern for anything, because the pattern has the side effect of introducing visible variables. Alright, so string is ints can't be in patterns, like int visuals. Same for strings, except it says string visuals can't be in patterns. Same for types. Yeah, type literals can't be in patterns. For structs, here is where it gets interesting. But before I get into that, enums, yeah. Switch. No, switch can't be in a pattern. And actually this is unreachable, I think. Yeah. because we only convert the left side of an assignment into a pattern, and that is guaranteed to be like a single line expression. And that means that a switch is always multi-line, so this is unreachable. Okay, if there is a name on the left, now this is interesting. Rather than looking up, we kind of do the opposite. We do visible.define whatever we had before in the other case. Yeah, this one right here. Visible.define name.string, and the value is going to be the thing that we are matching against. The thing that is currently being matched. This one. All right. Cool. Well then, yeah, lambdas. Ooh, what to do about those? Yeah, no, lambdas are not supported. Lambdas are not supported in patterns. So let's emit an error similar to this one. Oh. Yeah, and these errors, they are actually errors of nothing. And lambdas, boom, not supported. Lambdas can't be in patterns. Same for calls, by the way, which is like, this is quite big. Calls can't be in patterns. Variable definitions with like an equal sign and stuff like that, nope. Variable declarations can't be in patterns. Let's remove these unused bindings here as well. Alright, this here needs to return okay. And then bodies, not supported, I would say. Nope. Alright, so we have names. The only thing remaining is structs and enums. So structs. Basically, we want to check that this struct right here has every field of the struct that we are matching against. I think that's the case. If position contains x, y, z, I think you should need to match each of those. You can't write something like this. All of those have to be bound to something. Come to think of it in the long term, maybe I'll have something like this for kind of ignoring stuff, not binding that to a variable. But yeah, I don't know. Okay, so struct. We do have a field. We have these fields. I mean, okay, we go over each of the fields, first of all. And those fields need to exist in the value that we are matching on. So I think let's first do this. I get the type of our matched expression. And then I think we don't really need this. Nope. Nope. Well, I don't know. We'll see. We get the type of that, and then we need to make sure that every field in our pattern let's call this pattern. Ooh, that is cool. And then we have a struct pattern. Each field in our pattern actually exists on the type. So what we do is we check type.contains field.name, else, or we return an error. Pattern refers to field.name, but that is not in the struct, and then we have the type. Boom. All right. Oh, let's even get like the field source directly. That's clean. And then the other way around as well. Because we want all fields of the type to be bound to variables. Yeah. Oh, I see. This is not. Matched fields, maybe, yeah, have some sort of set, I guess. Yeah, this is, the fields here are a list rather than a map. So, let's do something like that. And then for each field in the type, oh, hang on. Yeah, we also need to check that this is actually a struct type. Otherwise, we return an error. And the pattern ampersand tried to use a struct pattern to match on a type that is not a struct, apparently. And then here we have the struct fields. Okay, and then for every field in the pattern fields, we make sure that the struct fields contains that field. All right. Yeah, we put those matched fields into a set, and then for every field in the struct fields, we just check that matched fields contains the field key. All right. Does not, otherwise the pattern does not bind the field something. Cool. And then, now that we've kind of checked that, first of all fields that are referenced in the pattern actually exist in the struct type that we're matching on. And we've also checked that all of the struct fields have corresponding fields in the matching, in the pattern. Now we'll actually compile those bindings. So I think the way that works is we will just go over the field patterns and then we will compile patterns again. So we'll kind of do field dot compile pattern. And we'll get the value out of the struct first. So yeah, basically we want to push a member expression, like out.member, I think that exists. Yeah, we know that that field exists in the struct fields. So we get the field type, then we turn that into kind of a member expression, turn that into an expression using the field source. Yeah, the member is going to be an egg member, which has an auth and a name. All right. All right. Yeah, let's get the name first. Oh, but that is something like that, I think. Yeah. All right. So let's say, where's the example here? We have a position, and we see there is this x colon a. So what we do is we go over each of these fields here, and for this one, for example, we will get position.x. We'll access the member of the thing that we're matching on, the member with the name of the field x, of the field type with the field source, all right. And then we will call ourselves recursively. We compile the pattern of our field value, aka this one right here, matching that field.value, and matching that against the actual matched value from the struct. Using, what is it, the body, visible, and context, something like that. Yeah. All right, and I think that's basically it. Here, let's add enum patterns and just not do anything in there. Oh, well, return okay, I guess. Sure. And we'll also need that up here. Cool. Let's see. All right. Oh, I see. Yeah, here we wrap that in an error. That makes sense. And we need to do the same thing for these. So hang on, toast expressions. Do they have a source? Not really. Right. No. But they do have some function, I think, for getting kind of an estimated source. Yeah, dot source. Yeah, so this will be an error. The message is going to be that, and the source will be pattern.source, called just like that. Okay, very similar for strings and for types. By the way, we don't need that. Very cool. Yeah, for structs we kind of handle that correctly, I believe. Yeah, for lambdas. This doesn't fit. Nope. And then bodies. Struct field dot contains. Okay, so we have a map. Oh, I see. This is string and source, so we do need to get the string out of there, and I think here as well. And this will be field name source. Yeah. All right. What do we have here? Yeah, putting the name in there. That is supposed to put the name string in there. This turns the name string. Apart from that, I think this looks fine. 429 in here, patterns. Pattern does not bind field. Well, I see. All right. Oh yeah, the module. I missed that. Not sure what I need that for, to be honest, but well, I don't know. Okay, all right. So this one apparently compiles. Let's see. It should tell me the X is not in scope. Oh, yeah. But when I do that, that's in scope. Oh, there's no function named plus in scope. Ah, well. Let's import that. Alright, that works. That's pretty cool. Okay. Patterns for structs. Yeah, I think I want to support patterns for enums as well. So if I have, you know, something like this, foo equals a, then a should be like foo high. Then here I should be able to do that. Yeah, enum patterns, that's the thing. So for enum patterns, we basically want to, first of all, make sure that the type we're matching on is actually an enum. Try to use an enum pattern to match on, well, something that's not an enum. And it has a pipe, I think. This pattern. Alright, then we need to make sure that there is only a single enum variant. So enum variance dot len equals 1, otherwise try to use an enum pattern to match on this. You can only match on enums that contain a single variant. And then we have the enum variance get 0, not 0. Enum variance. There's like a map, I believe. Okay, but we want to kind of iterate over that and then get the first one. and that gives us a map entry. And then we want to make sure that our enum pattern, oh yeah, that also only has, ooh, come to think of it, I might want to allow something like this. If you have an enum and foo and bar, they both contain an int, for example, I may want to allow something like this. But no, for now. I think that's fair. Yeah. Alright, so if the enum if enum same goes for the enum itself. There is only supposed to be a single variant. And then we have the variant of the type. So there's like the matched variant. And then we have the matching variant, that is well, pattern dot is similar iter next unwrap. And then we need to make sure that these have the same key. Yeah. However, this is, what is it, like toast enum something. As a toast type variant with a name and a type. So a toast type variant with a name and a type, and the name has to equal the matched variant key. All right. Oh. You know what? Maybe I don't. I'm just wondering, like, I would have to emit a switch, possibly. And then do stuff like. And you don't really use that, at least for now. I think I'm just gonna postpone that. Print. What you do in here, you just can't have enum patterns for now. I think that's totally fair. Yeah. All right. However, I do want to support patterns in one more place, and that is in matches. So in here, for example, well, that's a bad example. In here, yeah, a lot of these iterator functions, when they see, well, there was something more in an iterator, they just have this more binding. And then they use, more.item and more.rest. I think it would be pretty cool if you could just do this. Item and rest. And kind of automatically, get item and rest in scope. That would mean that this would just be item. And then this would be more with an item, that is the mapped item. And the rest would just be rest. Dot filter with mapper. Very similar down here. Stuff like that. All right. that's probably gonna be a parsing error, I assume. Yeah. So after the expected a name for the enum payload. Maybe remove some of the UI stuff in here. Expected a name for the enum payload, okay. Although I don't really want a name, I just want to have an expression here. Do I want to allow white space or dots? No. So this is the pattern, really. Yeah, this is just a expression. Payload is going to be an expression, yeah, and then in here we have the toast case, which we'll need to adjust in here, because this does not have a maybe something, it does have a maybe toast expression. Maybe call that pattern, I'm not sure. Sure, let's do that. Pattern, and then this is expected a pattern for the enum payload. All right. Very cool. I think payload is nicer, actually. All right. So this will probably fail when compiling patterns. Oh, there's like a maybe toast expression. Hang on. Baking to toast switches. Yeah, this is where I am. And then in here, well, this is a pattern. Oh, I see. Because that can result in an error, in which case we just abort immediately. Makes sense. All right, compile fine. Yeah. The case body. Yeah, we push some parameter of the payload type. True. The source of that will be the pattern source. Then rather than just defining something to be visible, instead we are doing pattern.compile pattern, using the pattern matching against the payload on the body with the module, the visible, and the context, and that may fail. Ooh, this compiles. That's nice. Let's see, and let's just fix this. And then let's adjust the iterators on general, like the standard library, to use struct shorthand and pattern matching wherever that makes sense. Yeah, here, not really, I suppose. Nope. And here, nope. And here, nope. And here, nope. And here, nope. And here. We don't have any structs, I believe. So. Nope. Iterators though. Alright. So filtering, yeah, we already did that one. Then here filter map, okay. Yeah, here. So this has an item and a rest. And then what we do is we create this more variant with, ooh. Yeah, I think it actually makes sense to keep the more here. Well, but here, this is just the item and the rest. And this is the item, and then we can also use the struct shorthand, like that. That is pretty cool. And if it's on a single line now. Yeah, that is super nice. Let's get the item and rest. Then with the predicate on the item, we just return that. All right. This is so cool. More B. More A. Ooh, like this is super nice. Here we can have item is item A and rest is rest A. We kind of do the same thing here with B. And then here we can just have item A and item B and zip rest A and rest B. Nice. All right, here we only use item and rest, so we can simplify this a lot and this a little bit. Nice. Then in here first, sure. Okay. All right. It's a bit confusing. Let's put parentheses around there. Item and the rest. Like, some of the code is really getting way more concise than before. I like that. Not so like this is not a nice name, you know, more. Like it only exists so that we can get stuff out of there. This feels a bit more natural. wonder about parentheses. I think you do need them on like a single line case. But not in a multi-line one. Which, yeah, I guess it makes sense. Yeah. I think I used too many parentheses that I don't need. Like these, for example, I think I don't need them. I'm not sure if this is super readable. You know, this is more of this. Yeah, sure. Like in here, that is pretty elegant, I think. All right. I think it's a bit more readable to have something like that. We chain together the mapper items and this one, and then we call it next. Yeah. All right. Nice. Ooh, expected value of variant. Oh yeah, let's do that. When parsing enums, I think, yeah, enum types, sure. Yeah, in here, think we do want to allow white space actually. Because we know that we only have a single variant. Nice. All right, yeah. I think I'm happy with that. Patterns, like these kind of patterns, they really compose well with the struct shorthand syntax. Like in here, for example, because you have these more specific types in scope, you can use the struct shorthand syntax way more often than otherwise. And here I think we can even do that. You know, things just generally get more concise because of that. Now hang on, I can simplify things here. Yeah, like this is beautiful, honestly. Such minimal syntax. I really like that. All right. Yeah. In general, I'm thinking about allowing more white space in more places. So, for example, we could allow something like this. You know, because this is the last argument to this call. Even in, like, if there were multiple calls in here, those would just become part of the lambda. But I don't know if that is confusing. You know, and like enums and structs and lambdas, they kind of eagerly or greedily consume stuff until the end of the line. So if they are the last argument to some function, then you wouldn't need any parentheses around them. Otherwise you have to put parentheses there to kind of constrain them to only consume this part. Like especially in code that does a lot of like iterator, in this kind of code, you know, being able to just do this is really cool, I think. Just saying .map and then you have the lambda there immediately. Damn. That is nice. Yeah, let's do that, let's support that. So I think that's in calls actually, like in expros, I guess. And then there was parse call maybe? Nope. Nope, not really. Oh, I see where this breaks apart. Yeah, okay. Like if you have something like this, and if we would say, you know, we allow white space in our arguments, then, well, we would give one argument to map, and that one argument is a call of the foo function with one argument, which is the call of the bar function, with one argument, which is this. So kind of we would always nest calls then. Except I think, yeah, let's just make it so that lambdas, they ignore the requirement of not having white space. Allow white space. Yeah, but we do allow lambda types and struct types and enum types, you know, that kind of have expressions with an introducing punctuation, ignore the allow white space setting. Allow white space setting. They just eagerly continue consuming stuff until they are stopped. So you may have to wrap them in parentheses. For example, when passing a struct to a call and wanting to pass other parameters after the struct. Yeah, but otherwise I think they should just ignore the allow white space setting. Does the same hold for types? No, because types don't have an introductory symbol. If in the code we have something like size, well, size is a bad example for that, but this, for example, then these should be separate types instead of being passed as your info string. Yeah, this may make sense for something like this, but I think it's fair if you put parentheses around it. This should not be valid. All right. Oh, we are only in parsing type. I see. Not sure about that one. Yeah, but the same holds for parsing types, actually. That makes sense. Let's ignore the allow white space here. If allow dots, then yeah, we'll just try to pass all of them all the time. Yeah. Let's just try that out. See what fails. Because I'm pretty sure like some things they will get parsed differently and stuff will not work out. Hang on. It does work out. Even better. Yeah. Like, that makes sense. Less parentheses. Pretty cool. Yeah, and I think this should be a general comment. Yeah, stuff like that. Cool. That simplifies a lot of stuff. Yeah, let's look at other stuff in the standard library, like in linked lists, for example. It does make sense. Here we don't need parentheses. Hell yeah. Yeah. Neither here, nor here. Okay, is that getting cursed at some point? I don't know. We have an enum more with a struct that contains an item and a rest, which then again is an enum. No parentheses needed here. Sure. I do have to say this is quite cool, you know. It's a more of a struct with an item and a rest, that is rest.iterate. Yeah, yeah. here, this is more with a struct with an item and rest.toList. I'm not sure how I feel about that. It is concise. It is yeah, I guess that's cool. Maybe it's just, you know, something that you have to get used to. In which case, I'm all for it. Okay, so here we don't need these. We don't need these even. Yeah, but you see it gets more difficult to parse, like which things are grouped. I mean, in this case, I guess, you know, that's just the entire rest of the line. And I mean, yeah, even in this case. But here the structure is a bit more clear, I think. And I think it's fine. Like, getting used to, you know, ampersand and pipe and backslash to be this kind of, oh yeah, these kind of wrap the entire rest of the line. I think you get kind of used to that. Yeah. So I do think I want some sort of reserve function for lists. Not reserving enough space for some number of items. Yeah, and that basically does this kind of thing. You know, it creates an array by just checking the list. Hang on, checking the list dot array dot len target len, I guess. Like if this dot array dot len is less than target len, maybe it does not have a reserve function for now. Yeah. Yeah, I think this is fine. We need some item that we fill that array with. Yeah. Okay, so if the array length is less than the target length, makes sure that this list can reach the target length without is true, then the new size. Is just going to be the target len, I guess. Or maybe the target length rounded up to a multiple of 2. Or to a power of 2. Yeah. Then we do list.array. Get maybe at that index, otherwise the default item. If that is fine, then we'll just take the array. Yeah. And then in the end we return a list with an array and the length, which is the current list length. Yeah. Let's also have an empty list, which takes a type. And that just generates an array of size 0 and just crashes. This is not actually called, but we cast that never to a t, which should work. What? Yeah. So then here we can just do empty list of t and dot reserve enough for one item, and then we push the a in there. And here we can do empty list of t dot reserve enough for 2 items, and then we push a and b. Yeah, and similarly here. We reserve enough for 3 items, and we push A and B and C. Whoa. Whoa. That is crazy. Yeah. I mean, we can directly inline that, I guess. Like so. Yeah. And then here we can just do is list.reserve enough to store list dot len dot +1 Actually, this is quite nice, I think. We reserve enough so that we can store the new LAN number of items. And then we can just return something with an array and LAN being the new LAN and array being reserve this dot array dot set list LAN item. All right. Well, no, we don't really. We only need the length actually. Yeah, this is a hack, so. All right. Hang on. Yeah, that makes sense. Yeah, here we don't need parentheses. Here we don't need them as well. Here we don't need them. Here we do. Here we don't. All right. I think I got kind of sidetracked there. So, but still, yeah, this seems fine. All of that is fine. I mean, what can I say? I am a fan of concise code, so. Yeah, could do something like that. Sure, why not? Also, no parentheses needed here. That is cool. That is really cool. All right. Let's see. Oh no. Oh yeah, that totally makes sense. Because that would just call concat of A. Oh. Oh, I see, because this is a struct with only a single field. Is that kind of hacky? Maybe. No. Tried to use workspace call list type. Yeah, we do need types. Oh yeah, true. These reserve functions, they need an element to put in there. Oh no, less than. True. Mm-hmm. Yeah. That is known at compile time though. Yeah, not the core part of this video, so I'm just gonna comment that out. And yeah, not worry about that. Ah, no, I can't do that. But this construct is a to-do, apparently. What's going on here? Why? Which function? Let's see. Yeah. Compiling a toast fun. And iterate. Well, that gives me some hint at least. Maybe this one. Maybe. Let's comment that out maybe. And see if that succeeds now. Or the error changes. Nope. be iterating over a range. That might be it. Hang on. Iterating over a linked list. Apart from that, no iterate function exists. Okay, why is this broken? If this is empty, then we want to result in the iterator empty thing. Otherwise, we have this more. Oh, this right here should, well, yeah. More of item at rest. Alright, and then here we have more of item at rest is rest.iterate. How about maybe stuff like this? Same error. Oh, I see. When we are compiling a function, and more specifically we are compiling a pattern. Yeah, for the struct we are looking at the type of the original struct. And then the fields, they have the type, just struct fields.get. That's not right. We actually want to take this type and extend that a model, like so. For every kind of pattern that we do. So this works for recursive patterns. Yeah, there we go. Okay, that's cool. So then, more concise syntax, here we come. This can probably iterate, just like ranges. All right, yeah. Look at this, yeah, and at this, yeah, and at this. Beautiful. All right. Yeah, I'm happy. We have pattern matching of structs, both for equal signs as well as in switches. And with that, I'm gonna end it there for today, and see you in the next video.